Hello, this is David, technical trainer for Robotiq, and today I want to give you an overview of our new machine tending solution. So the idea of this very short training, it should last about 20 minutes, is for you to understand the main outlines of the solution, the main features. We want you to be able to recognize a fit when you see an application where our solution could fit. And we want you to understand how this solution changes the game in machine learning application. You will see that we have a very specific approach, very new approach that will change the game in automation. Now, if we just look at the context and approach, so what we thought before deploying that solution is that nowadays it makes no sense to manually load and unload a CNC machine. Okay, because there is a labor shortage in a lot of territories, it's hard to find workers, to find skilled workers. So it makes no sense to assign a human to do such an easy task that can easily be automated. CNC machine tending is the quickest return on investment in all of the main applications. Okay, so this is another reason why we went with this. Uh, the CNC machines are currently not used at their optimal potential because they sit there, they wait for an operator to load and unload. If nobody is available, then they're not manufacturing, they're not doing anything, they're not returning their investment. So it's kind of a double return on investment here because the applications, the CNC machine tending solution, the Robotiq solution, will not only free a worker for another task, but will also improve the ROI of the CNC machine. And then workers, if we look at the last point here on the slide, workers can do higher value tasks. All right, so all of these put together mean that it's a good idea to automate a CNC machine application. Now, the current perception, what people think when we tell them that they could automate their CNC machine tending solution, they will see this, they will think it's complex, and they will think it's expensive. Okay, and with good reason, because standard or existing solutions up until today might be complex. Sometimes they need a lot of connection, some engineering, a system integrator to modify the CNC machine and connect inputs and outputs, and this can become expensive. So our main goal was to make this as easy and affordable as we could. So how do we make it easy? Well, Robotiq and UR Robots have more than 10 years proven in machine tending. We have developed, designed components that are used for machine tending. UR robots have been used for machine tending for years now, so we know we can already fit in this industry. Robotiq has a lot of support and documentation. So the support rate that we have when you call because you have a problem uh, with a Robotiq product, or when you write an email to the support team, we have near 100% support satisfaction rate. Okay, so this means that we have a very good support team that will help you in the field, you and your customers. We also have a lot of documentation. You know that we have ebooks, we have an e-learning platform, a very exhaustive e-learning platform that you can use, that you can look at, that you can use to train your staff. We also have a blog. We have a very complete website with case studies and whatnot. So a lot of documentation and support. The solution that we developed is a pre-integrated, ready-to-use solution. So the programming is simplified. There's no integration that is required. Everything is already meant to work together. Very easy to deploy, pre-implemented, pre-integrated. And it will work on most machines. Okay, existing machines, CNC, lathes, old, new, it will work on any type of machine. And you'll see why, because of our new revolutionary approach. You'll see it in a second. And we make it affordable because first of all, it is cheaper than most automation solutions. It will expand the working hours of the CNC machine at a minimal cost, so double ROI again. It's a standard solution. You won't need to modify, to hire an engineer, or to add modules to your CNC machine or your client's CNC machine. Everything can stay exactly as it is, and the solution will use the system as is. It avoids the need for a newer generation CNC machine. Um, Even if we're looking at an existing older machine with everything manual, push buttons, push pedals, no door opener, so the operator has to open and close manually, our solution will be compatible with this. So no newer generation CNC is not mandatory. The ROI is somewhere between 6 and 12 months, which is very good for an automation solution like that. So now let's look at this approach. So our approach, what we had in mind when we said, okay, we're gonna tackle this application, is a non-invasive operator-like approach, meaning that everything an operator does, we want the robot to do it without communication modules, without having to connect inputs and outputs from the robot to the CNC machine. We don't need to modify the CNC machine. Everything is just like the operator would do. We also are looking at a universal agnostic of machine type or brand approach. So this means that it will work with any type of machine, no matter the type, no matter the generation, no matter the brand. And finally, it is compatible with CNC millings or lathes, works with both. So how do we do this? Well, we look at the cycle of a CNC machine operation, and we do the tasks like a human would do. We're gonna pick and place parts, we're gonna open and close doors, start the CNC machine, wait for it to stop. So it means we're gonna watch the stack light to see when it turns red or green, for example. Then we're gonna clean the parts with air, and then to open and close a chuck, this kind of pedal might have to be used. So this is what we're gonna be doing with the robot now. So just an overview right now, and then we're going to look at those 6 steps one by one. So we're picking and placing parts with the robot. This we know how to do. We're going to open and close the doors with the robot. We're going to start and stop the machine with the robot and this button pusher. Okay, we're going to see it in a second. It's a pneumatic button pusher that can replace the operator. Then to watch the lights, we're gonna add those STACKLIGHT sensors. There are actually photo sensors that are monitoring the stack lights. So again, no modification required. We just want to look at the stack lights. Air cleaning of the parts and chuck, just with compressed air and a valve, okay, that we can control through our simplified software. And finally, we are going to open and close the chuck or the vise using this kind of pedal pusher, which can be done automatically. Now let's dig in. Let's look at all of those 6 operations and see what is the hardware and the software that we offer for each. So first, pick and place. So you're looking at the dual handy. Remember, handy is rated IP67, so it means it can work in dust and fluids. It is sealed. It is very compact to fit inside a machine. And we added new fingertips to be able to hold any kinds of parts that might be your reality. There's a larger one as well, and you will also find in the kit that there's a blank block that the user can shape to their exact shape and size. And just note as a side note here that any gripper is actually supported. Okay, so any other type of gripper can be supported for that machine tending application. We also have engineered a new, more compact dual handy bracket. So it uses the shapes of the handies to make it more compact. very, very small footprint here. Still picking and placing, so the hardware is what you just saw. On the software side, we came up with a part presenter software where you can set a single position, a line, or a trait pattern. And it's a visual tool that simplifies the program. Instead of teaching all the waypoints, what you do now is just teach the first, the last, or the corners, and all of the waypoints and approach points are generated automatically by the software. So it's very simplified programming. Second step is to handle the doors. So again, all we need to do is set a start and a stop position, and the force will move the door with a certain force to make sure we're not breaking anything and we are detecting that the door is completely open or closed. So it makes it flexible, it makes it force sensitive. Exactly, again, exactly like a human operator would do, push at the end and then stop. Then we're gonna clean the vise, the chuck, or the part with air, okay? So we're using compressed air and an electro valve that can be activated using an output of the robot. So we just need to assign the right output, and then there's going to be an air blast at the right time in the program. And the pattern is it can be taught by there are pre-programmed patterns that can be taught by only using a few waypoints. So we have the line, the cross, that spiral kind of pattern, and there's also the half pipe pattern. So by just teaching one, two, or three, four waypoints, you have a very complex pattern that can be generated very, very easily, more faster than with standard paths or waypoints with standard methods. Um, Now loading the vise or the chuck. Okay, again we have created a simplified loading program. It's a smart program. It uses force sensing uh, to find the vise and the stoppers, or to find the chuck and push the part in. You can set the number of stops that you're going to be using. You can set whether it's a vise, whether it's a chuck. It depends on your setup. Um, and again, a visual tool, easy to use. So just keep that in mind. And then that chuck or that vise might need a pedal to be actuated. So if a human operator has to push a pedal, we had to find a way that the robot could push the pedal. So this is why we came up with this pneumatic pedal pusher, actually. So again, it uses compressed air. The everything that you need air-wise is included: valves, manifolds, tubing, and whatnot. Okay, you will have this in the kit, uh, and it doesn't take off the ability to push the pedal manually. So with that pedal pusher, the operator can still use it normally, can still use it manually, or the robot can push the pedal. So we have both options as is. So we can also use some patterns. All right, it can be just a push down, a double push down, or we can hold it down if required and then ask it to go up. So these are all supported. Now, just as a side note, it's not to be used as a dead man switch. So it's not a safety dead man switch kind of pedal pusher. So if you're looking at those kinds of pedals, it might not be compatible, and it will not be compatible with the double dead man one as well for safety. In some machines they have the operator needs both feet there, so this might not be compatible here, mostly for safety reasons. All right, now we have to think. The operator pushes the the um, the start cycle button to start the machine. So we came up with the button pusher. It's pneumatic. as well. It can be actuated manually or automatically. So even if it's installed, an operator can still push it manually. Okay, it doesn't take up anything from the standard features of the CNC machine. The software can support up to 3 of them. The bracket is included. It's going to be stuck on the face with double-sided kind of tape, and you can download the template to make sure that it fits on your machine. So you can download the template, maybe cut it out, and then see if it fits on your machine. And then again, we are putting the robot in the mind of an operator. So the operator would typically look at the stack light to see that the cycle is started or finished. So again, we have monitor for light. So we have stack light detectors. 3 of them are included. They are very easy to install. They have the holder with just some cable ties or tie wraps to install them. It's compatible with most machines, and there's an adjustment for the intensity of the light that it needs to detect, so that it doesn't see just another light on the ceiling. Okay, so it can be adjusted to avoid false readings. Um, Again, you just want to tell it which one means the machine is idle or which one means the machine is running, and just add those nodes to the program. So when the machine is idle, then you can start the cycle, or when the machine is running, then you want to wait or whatnot. So those can be used in the program afterwards, a little bit like variables. There's three things that the sensor can tell. It can tell if the light is on, if it's off, or if it's blinking. Okay, it can tell 3 states, 3 conditions for each light. So that's very interesting. And keep in mind that it can only read if the light is on or off. It cannot detect the color. Okay, so if you put one on red, one on green, one on yellow, then you're good. Each can tell. But if you have one LED that changes color, then the sensor will only see it as on, off, or blinking. It cannot tell the color. So just as a side note. This still works with, I say, 80%, 90% of the CNC machines in the field. Other components you will find in your box, in your kit, you will find the communication module. I'll show you in a second, and the optional pedestal. The pedestal is very useful to put the robot standing next to the machine. It doesn't use too much floor space. It has to be anchored in the ground. It's optional, so any user can choose theirs. This one is very, very convenient, and the height is adjustable as well. Now that communication module, what does it contain? So the idea is we wanted to have all of the devices connected to that communication module to leave to reduce the number of connections that have to be done on the robot. So we just connect everything here from left to right. Okay, we see that at the far left, this is the power in. Okay, so it's gonna have a power cable, then the power switch and LED that tells if it's on or off. This is the USB port. There's a USB port. This is mostly for troubleshooting or firmware updates. You don't need to use this on a daily basis. Then comes the communication port. So there is a network cable, RJ45 cable from that communication module to the robot. And then this communication module will manage the monitor lights inputs, okay, 3 of them, and the activation of the pedal pushers or the button pushers. So there's 4 outputs for actuator, button or pedal pushers. Um, so we've seen all of those 6 subsystems. They are all put in a very easy to use program that takes the user step by step, and we have tested it. We're not just launching this on the market. We have tested it. We have at least one installed in a real machine shop here in Quebec, in Canada. They are running it, they are using it since January. We have updated, we have fine-tuned our software and our hardware using this as our use case. And it's in a real production environment and it works, and we know that it's useful. There's already a return on investment that was calculated. So we know that the approach is proven, that it works, and that we have satisfied the customers already. Um, there's a good payback even for small batches. So this was one of our main concerns as well. It has to be fast to program because when we have small batches, we don't want to spend too much time programming. So we calculated that it takes about 75% less programming time than with a standard UR cobot UR solution. Okay. So instead of teaching all the waypoints and all of the actions, there's a software node for all of the uh, sub sub actions. For all of the actions, there's a bit of software that makes it faster and easier. So above all, overall, 75% less programming time. That's very, very interesting. Now, if we look at other benefits, there's more parts produced per day because the robot motion and sequence is faster, it's optimized than with just standard waypoints. It's reliable from day one. Okay, the proven robot sequence eliminates all of the robot stops. As soon as you press play, it runs and it runs efficiently. It won't stop, it won't fall in singularity. There's a lot of double checks that are made in the robot motions pre pre-established by Robotiq. And then the same hardware with the same CNC machine, same robot, you can do more. Okay, so there's no changeovers or less changeovers. The same handy can handle different parts. The same system, the exact same light sensors and pedal pushers and button pushers. So the exact same hardware can be used for all of the batches, small, big, slow, fast. Same thing can work with many different types of productions. On the employee side, you'll find that this is a very interesting and very easy way to develop the skills of the employees. Because the solution is so easy, you can attract and retain your best workers by putting them in control and contact of the technology and productivity increase. So your employees will become more interested in what they are doing. They will be more interested in learning in high technology, and they will love working with the cobots. Okay, so this is very good for the skill sets because once this easy solution is installed, then they are using it, they are learning about it, and then they can be involved in other cobot projects in the future in clients' places. So just as an overview, we have a high level programming node called Smart Move. It's a very revolutionary way to move the robot where you just need to teach a few key waypoints and then the possible paths between those points. And then the robot will take over and generate smart moves and the best, more efficient moves out of that. So how does it work? The first thing you'll want to do is to teach the key waypoints. The software will walk you through this. So first you're gonna teach the key waypoints. Okay, so that's the rough positioning of the main subroutines or the main actions. So the first key waypoint you're gonna have to teach is just above the in-feed, so just above the tray where you're gonna pick parts or the blank parts to put them in the machine. Then you're gonna teach it where the door is approximately, just approximately, again, rough positioning. Then you're gonna take it inside and teach where the vise is. Okay, so again, just a rough position above the vise or in front of the chuck. And then finally where the outfeed is. So once all of those key waypoints are taught, then you can move the robot between those waypoints. So that's the smart move. So you're gonna hand guide the robot from one point to another by teaching it where it can move. So when in production mode, it will go from point A to point B by staying inside the path that you have shown without hitting an obstacle because it will stay inside that path. So it's a little bit like painting or modelizing where the robot can move. Okay, so this is what we're doing when we're teaching that smart move. So we're not only teaching a line, we're also teaching a zone where the robot can move without hitting an obstacle. So this can be done for each, between each part. And then we have the smart move. So then when the robot works, it will stay within those limits. It will find the best, more efficient move inside those limits. So you're making sure that you're efficient, that the moves are optimal, and that we're not hitting an obstacle, basically. So the machine tending solution comes in three packages. Just the core, okay, that is basically just the software and the button activators, air nozzle, and button pusher and pneumatic controls. You will find a single handy, and the recommended one for someone that starts from scratch is the dual handy with both handy, the bracket, all of the button activators, air nozzles, pedal pusher, and so on. So those are available there. All right, so I hope that this was useful. Um, I suggest you go on our website, robotiq.com, and look at our e-learning platform. We have a brand new e-learning that still gives you an overview uh, of that machine tending solution, and there's going to be a more advanced training coming soon. So keep an eye open, robotiq.com e-learning platform, and I'm hoping that we can discuss about your projects in the future. Thank you very much. Have a great day.